Let's look at number 9. It says the Stat Master computer game allows players to replenish their brain power. Look at their notes. 10% of the time after successfully completing a level. Consider the random variable x, where x is the number of levels that must be successfully completed until brain power is replenished. If we consider this to be to each level to be independent, then we end up with the geometric distribution. So it says, what's the probability at most 2 levels must be completed? That's the probability x is less than or equal to 2. And I'm going to use my calculator here. I'm going to use this function, the geometric CDF. CDF, and the probability of success is 0.1, and that's 2. So I'll show you here on the calculator. Second distribution, geomet CDF, 0.12, paste, go, 0.19. There it is, and I'll assume you can do that after this point. The next one says, what's the probability exactly 5 levels? So that looks like this. So this is the GMET PDF, because it's a particular value. And when I put that in my calculator, I get 0.06561. Letter C says, what's the probability more than 3? So I want to know what's the probability the number of levels is more than 3. Well, if I want to use one of these clever calculator functions, I need to use the CDF because I have an inequality, but I need to flip it around. So what I really want is this. So this is 1 minus the geomet CDF, again CDF, of 0.1 comma 3. Sorry, I had to cough. So I'm going to show you this. If I just go geomet CDF and I put this in here, I get that. If this was a multiple choice question, you know that's going to be one of the answers. Be careful. Don't forget to subtract that from 1. And so the last one, part D, says, how could you simulate doing this? And so here's the way I would simulate it. I'm saying let's make this easy. The problem is how many trials do I need to get that simulation, or to get that brain power replenished? So I'm going to let 1 equal replenish, and I'm going to let 2 through 0 represent not getting replenished. That gives me a 10% success rate, and I'm going to have to assume that they're independent. So this first time, it took me 2. The next time, it took me 3. But look, the next time, I didn't succeed. I didn't get there. And I didn't get there this time either, or this time. But this time I did, and this time I did. This time not so much. This time, yes. And I'm going, in my case, until I either get a 1 or I've done it 3 times. And so I could go through a couple of these and make the math work out good. I could do it 10 times. Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks like 10 right there. So based on my simulation of 10 repetitions, it will replenish brain power approximately 1, 2, 3, 4, 5 out of 10 times by the third level. So that's how I would work a simulation right there.